Thank you very much, Dr. Schumacher. Our first distinguished guest, Dr. Amit Sheth, is an educator, researcher, and entrepreneur. He is the LexisNexis, Ohio Eminent Scholar at Wright State University in Dayton, Ohio. He also directs the NOESIS, the Ohio Center of Excellence in Knowledge-Enabled Computing, which works on topics in semantic, social, sensor, and services computing over the web in social cyber physical systems. Professor Sheth is an IEEE Fellow and is a highly cited author in computer science, World Wide Web, and databases. He is the editor-in-chief of the highly ranked International Journal of Semantic Web and Information Systems, the joint editor-in-chief of Distributed and Parallel Databases, series co-editor of 2 Springer book series, and serves on several editorial boards. By licensing his funded university research, he's also founded and managed 2 successful companies. Several commercial products and many operationally deployed applications have resulted from his research and development. Please help me welcome Dr. Amit Sheth.
Thank you very much for the introduction. Thank you, Dr. Schumacher. Thank you for the committee to invite me here. It's a great pleasure. I did not hesitate to take the chance to come back here again. In fact, there are many occasions I am reminded of my association with UGA and with the LSDS lab that we worked together on. And there are many other, for example, next week I will be having a lunch with one of the alumni from LSDIS that is currently serving as the interim CTO of AOL's Huffington Post unit. I just had communication with Kemafor Renenu, who graduated in 2007. My second to last PhD student from here. She now has 7-8 PhD students of her own and is firmly established herself at NC State University. And there are many such examples. I go to California and we have alumni lunch or dinner, and a number of students that graduated from LSDIS and from UGA show at those meetings. So let me show you, in fact, another way how we are associated. You might be not aware of that, and if not, you should be. Here is a list of, this is a couple of months old data, but you can go to Microsoft Academic Search and look at the 5-year impact or 10-year impact of organizations in a particular field. In the area of World Wide Web, which is where LSDS lab used to work and I assume still works. Here is the ranking, to some extent surprising. Look at some of the big companies and some of the much larger departments, and here we have University of Georgia. Of course, Wright State also shows up now that I've moved. It's just something to be proud of. We are both UGA, Wright State, we are small fish compared to all these huge universities and much larger organizations, and yet in one particular measure, we do get ranked and recognized at that kind of level is quite amazing. So, of course, it's a challenge to both Wright State and to University of Georgia to work hard to keep such a ranking. This is way too prestigious, and I hope that we can continue to do so. So, let me also give a very brief introduction to NOESIS Center, which kind of carries on what we started here at LSDIS. We are 15 faculty now at NOESIS. There are 50 PhD students. It's a multidisciplinary research center. Almost all faculty have funded, pretty good funding actually, new building and so on and so forth. So it's been a great, but I still very fondly remember my time here. So with John Miller, I just see him here, he showed up. We had a great time, and both Budak and the Sendis project. Chris was there. We did some pretty exciting stuff there. And just I think a month or two ago, I did a proposal with Budak and Lakshmi. So the things can continue on with Prashant. I still have a jointly funded NIH grant. All right. So on to the talk now. I'll be more than happy to entertain questions now or later. Originally, I'm going to basically use a keynote that I had given recently at a conference, and there was more time there, so in parts I'll be skipping around. But I thought I would share with you what I think might be a very exciting idea for the future. Some of you who have seen and worked with me know that I try to the best of my capability to kind of look beyond what is now today, rather than continuing to work on the same thing for many, many years. When the top, much of the issues have been already explored, I like to look into something new. And here the objective is very clear for what I want to do. I call it computing for human experience. And I have an article in IEEE Internet Computing. There's a vision issue last year. Much of the computing we do, we really have to think about communicating with the computers. So we have software developers, we have computer science researchers, we have programmers, really have a good sense of how computing works, how computers do their work, do their processing. And we translate our human needs into the form that computers can get done, into the computations that that can in part solve what we are looking for. Suppose we have a huge amount, massive amount of data, and we want to do mining. Well, it's not that we really want to do mining. It's that we really want to leverage all that data to make a decision that either helps us find new drug targets or help find unexplored data in a way that I can have completely advantage in making the stock bet. So we are looking for insights or ways to make better decisions. And for that kind of purpose, we are utilizing computers. But in much of the things we have been doing all this time since the computers came into existence, is that we used to learn earlier machine languages, and some places it's still being taught. We learn programming languages, and we learn data structures, and we learn the space-time trade-off and all those kind of stuff. But if you fundamentally recognize and think about the process, it's human coming down to the level of best matching, translating his or her problem into the way computers can solve them, help them solve them. Why not get out of that rut? And why not think about, let us build a technology framework and environment whereby it is there to serve humans without humans really working hard at making computers and machines help humans. So what is it? So what would that be? So that is a computing for human experience. The idea is that we have one world, 7 billion people, but we live one experience at a time. Right now we are sharing the experience of this particular conversation that we are having. Farmer is sowing, we may have family vacation, but constantly we have stream of experiences that are cultivated, realized, shared, remembered, enjoyed. And technology today increasingly engages individuals, society, humanity. It is for the first time in the human history that we have a device, mobile phone, that has become a tool for majority of the humanity. Never in the past that was the case. That was not the case with telephone, that was not the case with TV, and so on and so forth. So we have computers, billion of computers, we have 5 billion mobile phones. In 2008 or so, we had 40 billion plus mobile sensors. Now, with all that, we're constantly connected to the global network of data, knowledge, and people. So, how can we leverage all this technology to improve our experiences, our decision making, our insight capabilities, without losing ourselves in the process. How do we not drown in the data? So the idea is that we want to go from machine-centric to human-centric design. And I'm not talking here about a topic that has been well investigated and still continues to be important. I'm not talking about HCI, I'm not talking about human-computer interaction per se. You'll soon see how what I'm talking about is different. But we want machines to accommodate our experiences as opposed to the other way around. And we want computing to liberate us. So to do that, let's take a holistic view of computation, where as we have a shared universe populated by people and machines working in harmony to achieve a highest aspiration. Our life, our humanistic experience. Now, I'm not the first one to talk about some of the things I will talk about. There have been some wonderful visions over the period of time that I've had a chance to be exposed to learn from. There was a very influential and seminal work by Vannevar Bush in 1945. He wrote an article, As You May Think. It still remains one of the seminal piece of work in computing. He tried to think about, in those days in 40s, how to mimic human brain. How would computing mimic human brain? And that remains still an important topic to investigate. Mark Weiser talked about ubiquitous computing for the 21st century. My good friend Ramesh Jain talks about experiential computing, humanist computing, urban intelligence, man-machine, symbiosis, O'Reilly. So we want to talk about the ways in which technology and humans interact, that aspect is now fundamentally changing. With that change, though, human experiences is changing. The amount of data, the amount of knowledge that we have at our disposal has changed in the last 5 years. Our activities, decisions, thoughts, feelings, these are all affected by this ubiquitous integration of technology into the fabric of our life. So that is what would lead to computing for human experience. Here is a list of a set of some of my team. And this is an exceptional piece of work. Some of you may even recognize Corey Hansen, for example. He's doing fantastic work, and in fact, some of the things I'll talk about is what he's working on now. Now, the thing that I'm intrigued about is to improve human condition through computational means with minimal burden on humans. And what we want to do is to better support human capabilities, such as sensing. For example, human vision is extremely complex. There are 30 different aspects of the vision. Like there is a special part of the brain that knows about moving of the object. And if that is so, there are other things like perception, attention, memory, decision making, control. So consider this example of what we need to do for this kind of stuff. A plane going across the continent generates 240 terabytes of data. And you'll hear about this in big data and other contexts. What I'm interested in is, though, of this data, what does a human get? A machinist on the ground would probably be interested in that half a second worth of period where there was severe turbulence and plane might have reacted out of the bounds of the kind of behavior they expected to have or supposed to have. So, from all this massive amount of data, the thing that really matters to humans, we made the planes to make our lives easy. Well, what matters to us from all this data is something very, very focused, very limited, and at much higher level of abstraction. None of these humans who will ever, analyze, who will ever even be aware that there is such amount of data would care about all those bits and bytes. They care about making a decision whether the plane reacted appropriately or not. where they drop the height too sudden and too much for what reason, right? So you need to come out from this low-level stuff and data into something that is a lot more meaningful to humans. Now, I'll take in my presentation some examples from health, possibly health biomedicine kind of stuff. To be able to do what I'm talking about, we really need to pay attention to a lot of different kinds of data. So if you talk about, let's say, health, you have medical records, you have background knowledge, UMLS and things of that nature, you have social networks, you have observational, personal observations, so how do you feel, you have sensors who might be taking your vitals and so on and so forth. And really, much of the decisions that you would make for human health would leverage, in reality, would need to really leverage all these different things. Otherwise, computers can't really help too much. So, otherwise, much of the work will have to still continue to be done by clinicians. And that may still be okay for a little while, but the idea here is that how can we bring together all there is to know and all that is important in making the decision. And very often, so for example, the work that we have been doing, we did at LSDIS lab, and I continue to do that, and integration of data continues to be very, very important. But it is not just going to be about continuing to integrate the data at the data level. It is to integrate all this kind of data at a level that makes sense for human decision making, at the knowledge level. Right? So, one of the things that is happening these days, there is a big movement called quantified self. So, humans are taking all kinds of sensors. Fitbit is one of the very popular ones, where they have it on them, and these sensors continuously monitor some aspects of human health, fitness, and well-being. And they generate massive amount of data. Again, from all that data, what do we care? Well, only something is important and meaningful and relevant to human decision making. So, the idea here is that if these sensors and the applications with the sensors will give you this kind of information, that's not going to cut it. That's not going to give us what we need. That won't improve human experience. What we need is not only just something like a dashboard where I can even see an integrated view of that. What we need is, from all this data, is there something significant that is happening to my body? Have I come short in my objective of my level of exercise and activity that I should have today to meet my objective? These are the kind of things that we need to take all that data from. So, being an educator in part, you need to make it pedagogical. So I kind of simplify the problem to talk about 4 issues. And today I'll talk about maybe just a couple of these 4 issues. Integration of heterogeneous multimodal data, and I won't talk about it. We've done work in that past. A lot of people have done good work in that past. It's on this topic. Bridging physical, cyber, social divide. This is a relatively new topic. This is a topic that needs a lot more attention. People are talking about cyber physical systems, but now it's not just physical and cyber, it's also social and everything that come together. And how do you leverage it? How do you data and information and knowledge at all this level integrated in a way to solve the problem that humans have? Elevating abstractions that machines and people understand. This is our newest work. This is what Corey Hansen works on. So the idea is to convert from this low-level bits and bytes to something at a human perception level, right? Not just machine perception, but human perception. And semantics at extraordinary scale. Do this at a scale where, if necessary, I have ability to understand what 20,000 sensors about weather in the whole of US tell me, or what those 40 billion sensors have to say about what I'm interested in. And all these things are brought together, at least as I see it, in part through the semantic web technologies. And along with that, a lot of other things, NLP and machine learning and many other things. So, in fact, so happens that at Noesis, we worked at all these different levels. What we do is to see how semantics improves cloud computing related work, web services, and that kind of work we did quite a bit here. John and I worked on services and semantics for quite some time. At sensor, semantics applied to sensors, social computing, which we do now very aggressively, and and then for knowledge discovery and all that. So here is about integrating heterogeneous multimodal data. These are broad variety of data that we can talk about. Even in the context of health, there is a huge amount of health social data. That 60% of physicians either use or are interested in using social networks, and people rely on other people to make their health decisions. 83% of adults search for health information online, and so forth. So, in this context, we do a bit of work. Let me, in fact, just take a little detour and tell you how something we do in social data gives you insight. So this is a system that processes online, and all this time is, I think, a network and other things. We essentially analyze all the tweets that come in on topics of interest. The topics of interest could be US healthcare election or Occupy Wall Street. And this is kind of real time. So just as we speak right now, in the last 1 to few seconds, last minute, these are the tweets related to US election. Or in the last few, so you can see, well, we are in Georgia, there's nothing from Georgia on this thing, but, or maybe this one. Mitt Romney buys Worcester HR block franchise to keep whatever, right? And this is a 10/16, pretty recently, and so on and so forth. So, it can tell you what are the topics of interest that people have. Here is a very interesting thing it can tell you. On Occupy Wall Street, you can ask question like this. Who are the dead people that are mentioned in the context of Occupy Wall Street movement? Answer probably, if you think about it, won't surprise you. The answer until yesterday was Rosa Parks. Now it could have changed today, okay? But let me see. What is because, oh yeah, it is Rosa Parks. You can see. So, and that makes sense, right? People are making an analogy between the civil rights movement and the struggle and Occupy Wall Street. And it tells you sentiment. For example, on the 5th of March, we saw that in Ohio, the day before Super Tuesday, Centrum, sentiment towards Centrum and towards Romney crossed over. And indeed, Mitt Romney won by a little in Ohio. So these things gives you a lot of insight into network analysis. It tells you in the context of, say, Occupy Wall Street, how are people how are people getting their work done, or how people are coordinating. See here, Occupy Wall Street, you see that people are not very well connected. There are a lot of unconnected nodes here, clusters. You look at Occupy LA, and you will see a very different behavior here, much better connections between all these things. Now I can turn the same thing on the biomedical literature data, biomedical data. I can do the same thing on the health. I can do the same thing on any variety of different things. And in fact, we have done that. I am not going to spend too much time. You can go yourself and look at it, the archive event, the Japan earthquake and tsunami, and you can look at Osama bin Laden's killing and so on and so forth. So all kinds of stuff can be investigated, and we have done so. But the point here that I want to make is that we are developing. This is an example of a technology where a small amount, a massive amount of social data is dynamically converted into insights. The insights, what were people talking about yesterday? Where are the swine flus nearby where I am? There is a part I did not show you where it will do geospatial slicing of the data and tell you what's happening near where you are, as an example. Who are the people who are talking about the same thing I'm talking about near where I am? I can do all this kind of stuff, right? And these are the things that are necessary, because when we humans make decisions, we are attuned to this thing. We read news, we read, people tell us about something, we hear on NPR. All these things are constantly being digested by our brain, filtered by what is of interest. So I'll obviously not pay attention to a lot of other things that are happening. If I'm visiting UGA today, I probably won't pay attention to something that's happening in downtown there, but I'll probably pay attention to something that's happening related to computer science department. So that we do that, these kind of systems can be created to do that on a massive scale for all kinds of events that are occurring out there. In fact, we are creating a version that are personalized in nature, where the Twitter system that I just showed you, you will have a version, we are developing one for a politician. He's a well-known politician, I can't tell you the name right now, but he wants to see all the discussion in the media from his perspective. And he wants to see which media outlets are negative on him and positive him, and he wants to see who are spreading rumors or incorrect facts about him and want to go about, addressing this and so on and so forth. So we can make it very personalized. Now, and this is about interfaces that are bringing all these things to us, quantified self, I already mentioned. By the way, some of these things tweet. We can have one of these sensors and then we can treat it. So then we can use tweet trees, right? Here is something about tweet trees I already showed you. Let me move on faster. We could hear, it was showing an example of in the Iran election, what people in the US talk about versus what people in Iran talk about. So all kinds of interesting things. And here is a very interesting example. We are applying on the fly, on the Twitter stream, a domain model that is created on the fly from Wikipedia. So using some key terms, we give it to this tool we have Wizard. In fact, Christopher Thomas, who was here with me, developed that. So that here you can see a domain model. This is dynamically created from Wikipedia, and that is applied. So I know that this place, Heliopolis, is a suburb of Cairo. And this we created on 29th of January. On 30th of January or 1st of February, I think 30th of January, there was this million-person march. And this will help you understand that the procession is taking this route. And there's a word here, and that's a suburb. And that is part of the route. That kind of knowledge can be applied by the system. So here it is showing you the application of this kind of stuff in many different contexts. Let me just breeze by as fast as I can. It shows you, Azadi Square is a city square in Tehran, and so the next thing that I want to talk about is abstractions. They provide the ability to interpret and synthesize information in a way humans to effectively understand and communicate ideas, feelings, perceptions. And so this is one of the interesting things, and there's a lot of work. So the idea is that you have a lot of real observations. Sensors create those observations. The tweets are observations. Humans have observed something, or they have feelings, and they're sharing with the rest that you can do. And then from that we want to create perceptions, something at a high level abstraction. So here it demonstrates how we use a whole series of ontologies that observer observes quality, that we have, there is a sensor observation ontology. So Corey, I co-chaired a W3C group on semantic sensor networking, and there is an ontology for sensors, and it can help you model these. Here, we are talking about something like quality inheritance entity, and in this case, redness of an apple. This comes from a domain ontology. These are kind of ontologies like the ontology that you still have called LICO and so on and so forth. The ontologies like those help you interpret it. Linked data can be used to bring in background knowledge. So here it shows that we also published some bubbles there. Here perceiver perceives entity, and for this we done some original work in development of what we call IntelliGo. So, and then the idea is that one of the powerful reasoning that human applies is adaptive reasoning. It has severe computational challenges, so to model with some assumptions, part of these through parsimonious covering theory into deductive logic based reasoning and make it more efficient. So that is the kind of work that we are doing, I'll not go into the theory of that since we have limited time. But at the end of the day, this helps us build a perception cycle. We observe something, but we think that when we relate to something else, we ask, focusing, meaning say, give me something more about something else that is related, and that creates a cycle. There's well-known work by Messier and many other people in perception. So, again, I won't go into those things here, but essentially create a cycle of a machine working with humans in helping understand on the behalf of human things of interest to human. So let me show a couple of examples. This is an example of real-time feature streams. Let's look at that example. Oh, I should have asked, there it is. I think we heard sound. Wonderful. Is the sound thing on? Let's hope that it. Okay, the sound is. I think we did not turn on the sound. We'll see. Maybe that's okay. If I can't hear it. This system shows real-time analysis of sensor data, and it helps you find weather phenomena of interest. So I'm going to, let's say, drive through this particular road, and will there be a difficult, think about John driving in winter to Indiana. And he wants to figure out, hey, if there is a, very bad icy road condition on the way. This will give you in real time on your road whether there is icy road condition or not. So, so anyway, I assume that that is what we can do. In fact, let me see if I can have this demo queued up to go.
Observing their environment. All these observations are conditions. Data on the web also represents the vast collection of human knowledge and experience. Machines, when given access to this huge knowledge on the web, are empowered to interpret their observations and turn them.
I'm being greedy. I'll show you the last thing and now.
Interpret their observations and turn them into humanly intelligible abstractions. The ability of machines to interpret observations and derive concepts or abstractions can lead to powerful and smart machines which enhance the human experience. We present a semantic web research effort towards a physical cybersocial system that exploits background knowledge and an intelligent perception utilizing abductive reasoning and realizing thinking. In this demo, we present Secure, a system that can detect and identify a fire from a mobile platform with sensors sending real-time data streams.
See, at the end of the day, human cares whether there is a fire and what kind of fire there is.
Processing real-time sensor data to derive
Depending on the type of fire, you have to use different retardant. And it does not care about the CO2 or doesn't care about the actual temperature. So basically, here you have a robot carrying multiple sensors, and here these are the raw sensor data. And here you are actually seeing the perceptions, things that matter to human. Here you are visually going to see whether there is a fire or not, and possibly even what kind of fire there is. So there's knowledge base that also, and reasoning on that, saying helps you understand the type of fire there will be. Exactly where it is supposed to show it, in a microsecond, yeah, there it is. Okay, well, that's that, enough. So, let me see this thing, show it here, but see, it shows here, a particular weather phenomena of interest. So the point here is that even this kind of system can be built. Idea here is that a lot of sensor data can be processed and reasoned about to give you things of human interest, things that human care about.
So can you go back a couple slides?
Yeah.
Is that the weather in Dayton there?
It could be, but it is not. In fact, we actually had one of good friend remark, the reason I did not move to Dayton is it's too cold. Actually, 2 of the 5 winters that I've been there are good or cold, but the 3 were pretty good. And on the other hand, every day, starting from May through middle of October, we can sit outside and have dinner without insects. So here, let me talk about, instead of slides, let me talk about one very exciting thing we are doing right now. We are equipping, so the problem is that of, one of the big healthcare problem today is that of high hospital readmission rate. So for chronic heart disease, 24.8% of the patients get readmitted, costing US healthcare industry or healthcare system $17 billion a year. So the idea is, so we're working with cardiologists at Ohio State University and other cardiologists elsewhere, where the idea is to equip patients with very low cost, less than $100 sensors, passive sensors that communicate via Bluetooth to a system that reasons and converts all these raw signals. See, all these signals, nobody's going to be able to pay attention to all the signals all the time, neither patient nor doctor, nor nurse. What is important is whether patient from low risk has become precarious or medium risk or has become severe or high risk. And when if such a stage is reached, then what is the result? Is patient starting to retain body fluid, which is one of the things that happens with the blood with the cardiac patients quite often. So converting that low raw signals into these things about high risk or precarious health conditions is another example of the kind of things that we are working on, which is again some of the early example of what I am looking for in the company for human experience. Here I am talking about being able to scale with the data. In 2008-ish, we lost the ability to store all the data. The amount of data we generated surpass the ability to possibly change, to store the data. And so this is going on, in fact, going at a very fast rate. And one of the things that we do in these kind of systems is to show how, when you go from this raw data to convert into high-level abstractions, how you are significantly reducing the amount of information available. And that's it. You want to change the problem of data analysis into problem of information and knowledge and insights and decisions and just those things that are contextually relevant to human decision making. So with that, let me see. There is a lot more into healthcare application that I can talk about it for quite some time. Let me bypass here. But here is showing you the kind of things that we are doing. The application can interact with the patient, asking contextually relevant questions. Patient is, having low blood pressure, and first one of the things the system can is, did you take the medication? But some of this can be rather easy, other can be far more complicated. It's not as simple as simply asking for medication. So, here these are things being converted, health signals, so I will not discuss that. So, to kind of wrap it up, computing for human experience holds the potential to revolutionize the practice of healthcare and many other disciplines by embracing relations between ourselves, our machines, and our health. And the idea here is that this is a beautiful line that Mark Weiser wrote in Computing for 21st Century in his 1991 article. The most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they are indistinguishable from it. And Google's Project Glass and many other things are addressing some aspects of that. The important takeaway I would like to make here is that there's another interesting project I must mention. There's a project called Sixth Sense that Pranam Mistry at MIT also worked on, gesture computing and how system understands human gestures and communicates what human is trying to do, like this is taking photograph. That's wonderful. Siri is another very good example. However, for the real breakthrough, it's not just that human can communicate through much more intuitive user interfaces to the machines, but to actually change the whole background knowledge processing and information processing in the machines from low-level data processing to the ability to get these so-called semantic abstractions. And just the same way, we think that our human brain is not processing every bit of data at a very low level. Yes, there are many neurons and they process a lot of data, but it has the ability to go from that data and take it near to human senses, human perception, human cognition, and human action. That elevation from data to information to knowledge to insight and decision is what we want to do in this context of computing for human experience. Again, to bring back the core of the technologies and research needed, integration, physical, cyber, social, abstraction, and doing this at a very large scale. So that is computing for human experience.
Does anybody have any questions for Dr. Sheth? Yes, go ahead. We have a microphone here. Do you think it'd be okay?
Yeah.
Okay.
Where does high performance computing fit into this? But it looks like there is also data processing.
There is a lot of data processing, but it's the same way. Let me give you I think that we should not be, so the message that I want to share with you is that we can't do the data storage in a dumb way. We can't even afford to or try to store all the data we generate. In the same way, we should not also simply throw computing at data processing. Our ability to create data is continuing to outstrip our ability to process the data. In many examples we know that is already there. So the issue here is that so high performance computing is going to be necessary and needed to save. And all the more, much more than the traditional high performance computing, which itself will continue to be important, the distributed processing, parallel processing, and all those will be very important. And here, what we need to change is that, think about today data structures. All the data, is at a same level of abstraction. Instead, we need to change to the data that is pegged to ontologies or to models, and see there in the high level of context. Our weather sensors create all the data every second, maybe, or multiple recording of different kinds of phenomena per second. Maybe that is fine, but after a week, you only care the average temperature, high and low temperature for the day, and not temperature at every hour and every minute and every second. So there is a form of abstraction where at some point of time, rather than think about the data at the low level things, we want to talk about higher level, median temperature or high temperature or something along that line. Or going further down, in a month, was it a hot day or cold day? Based on the average is what becomes important. So the notion of the hot day and cold day is different than the fact that the temperature is 35 degrees. And it is that kind of abstractions that we need to bring into our computing infrastructure, so that we won't have to try and simply rely on number crunching and string manipulation and that level of things. There will continue to be string manipulation, but not for the purpose of that data, for the purpose of the human concepts that we care about. So in that sense, I would like to see that the computing as such, including high performance computing, moves, engages and brings in these different levels of abstractions and a lot more endemic and unique understanding of not just data but the information and knowledge that it relates to. That is what I, at least for the purpose that I
mentioned that there will be like thousands of sensors or something to get the data from.
Billions. There are
Yeah,
billions.
billions. So that means lots of power.
Yes, and but remember, there are 5 billion mobile phones. Majority of the mobile phones sold in India today are smartphones. They are all computing platforms, for that matter. Another very important thing is that at the end of each of those phones are human beings. They are smart people. They have very smart computer here. So the thing is to kind of bring about, go rather than unilevel, singular level of computing and abstract things, we need to kind of bring in the richness that the human life has. We have expertise of different people. We have different conservative versus liberal. A lot of richness of this the real life has, and we need to think about combining computing with this real life.
Yeah. So I guess there are two sides of this coin, if I understand correctly. One side is that yes, the humans would like to have more information in their day-to-day lives. But then on the other hand, there's also the question of information overloading. And so when you present all this information, obviously if you don't want to get overloaded, you can just turn it off. But then are you looking at ways of better presenting the information to the user or the human?
Absolutely.
Less information overload and
Absolutely. If you're going to serve the human, you need to know human needs. And you're not going to tell the humans all the things that are. Me as a person, I'm not interested in an accident that is happening on the road that I'm not traveling very most often. So the system really needs to understand the context and the human needs. So I did not more explicitly say that, but when I say that the system does all this processing, for that 240 terabyte of data that plane generates, the system would generate very different thing for a pilot and very different thing for a mechanic on the ground and very different thing for the plane manufacturer. So the abstractions that any one of them will be interested in will be contextually relevant to them, their needs, unless the humans explicitly ask for it. So there has to be a very strong notion of context, personalization, filtering of these things all the time. And suppose we have 1,000 sensors in this room, what you want from those sensors is different than what I want from the sensors. And then that is what the system has to understand. So when you are trying to achieve, the computing being disappearing in the fabric of the life, we better pay strong attention to what the human interests are and what human life is about and what human experience is about, what current experiences human is interested in. So that's.
But I think that in that sense, there is a strong connection to ACI, because ACI also looks into what the user wants and what the user model is, what the mental model of the human is. And so in order to do a good level of context awareness, I think you have to look into the mental models of the human whose data you are providing.
Right, but there are two ways of looking at this. The HCI itself either has to transform and is transforming in a very different way. Okay, so HCI is no longer about your interactive computer screen and GUI and all that. HCI is about. So the point here is in this environment. Let's say think about ambient intelligence. The sensors are there. They are supposed to observe and at least try to guess the human behavior and needs and interests, and possibly intervene or even giving human more information is an intervention, and do that only in appropriate way. Otherwise, you will say you're bothering me. So. To the extent that you are noting that SCI research does involve work on context, that's absolutely right, and that's perfectly relevant. The same way, though, the important point I want to make here is that, and I'll give you one specific example. You look at beautiful TED talk that on the sixth sense, but think about it. All the examples that are in that TED talk are really not doable in any scalable way unless you have scripted them, at least. Unless there is a very comprehensive background knowledge-based intelligence system. Just the fact that my machine understands that I am holding a book doesn't tell you about all the processing that has go about, well, what is this object? It's a book. How do you characterize a book? What is the model of the book? What is the ontology of the book? What is the description of the book? What are the features of the book? What is the relationship to this gesture, and what it may mean to computational support that it needs to have to provide? Is it that he's showing ISBN and hence you're looking for review, or is he looking for price, or both? These things are going to require a lot of processing in the system. So what I like to do, what I like to say is that those things like talking to the system like Siri or Watson understanding your question, these are very important things, and we have made great progress. But they are supported by, or they will need to be, such things will increasingly need to be supported by all that massive computational infrastructure, intelligent computing infrastructure that has to go behind it. So just take the example of Watson, the amount of computing and other things that has to occur to support that interaction. Interaction is a very minuscule part of what is necessary to actually give the answer. And paying attention to all those things that goes behind is very important. So to me, human interface, many of the human SCI is a surface part, extremely crucial and necessary, but far, far from sufficient part of what needs to be done in making the systems useful to the humans.
I believe we have time for one more question.
Yes, thank you for the very visionary and excellent talk. So my question is, given the trend of human-centered computing and a key issue is how to understand people or human brains' perception and cognition. So for example, brain imaging is a tool to read people's mind, but brain imaging is not possible at all. So can you provide us some insight what kind of tools or approach can be used to infer people's perception and cognition possible tools so that we can do more human-centered computing? So.
Great, you're asking this question, so I have something very relevant to your question. I've been reading this book here, V.S. Ramachandran, The Telltale Brain, Unlocking the Mystery of Human Nature.
Mm-hmm.
Amazing piece of work. Ramachandran is in the modern, maybe a miracle sort of work here. But he, for example, talks about these 30 different units involved in the human vision, as aspects involved in human brain to support vision. Eye has very little to do with vision. It's necessary, but eye does not recognize the objects. It's the brain that recognizes objects. And so when you think about that, such a thing can help us understand, like this way human brain specializes for something and yet communicate. So there's a part of the brain that talks about the movement I mentioned earlier, and there's another part that actually associates with the object itself, and there's another part that invokes emotion about the object, for example, right? So one approach is to kind of really understand the brain and directly try to implement it. I'm not there. And I wish all the success to that approach, and it's a great research objective. I'm interested in learning at a high level how such a complex thing is done by brain, and now how all kinds of things like sensing and interactions and knowledge, because our brain is so powerful not just because we recognize something, but we also have knowledge and experience. That is always applied in anything we do. The same way, we are going to have reasoning and processing, but we are also going to have knowledge and experiences in our system. And so the kind of system that we are looking at here is to try to say, hey, can I go from low-level data to something that is high-level abstraction? Beyond that, when the object is we are dealing with complex thing, what are the different things involved and how do you make the specializations and yet how they collaborate? So these are the kind of things I want to learn from that and then try to do that. So there will be more of a very gross level of approximation or using the brain as a to get inspiration, but not necessarily try to physically do anything in the way the brain does. Right? So I think that's how I would answer your question.
If everybody would thank Dr. Sheth. Now, before you go, we have a gift and certificate we'd like to present to you. This is on the behalf of the department. I'm sure you have plenty of things to carry right now. Thank you so much for coming. All right, at this time we're going to take a quick 15-minute break, and I would recommend that you please partake of the refreshments in the back of the room.